G'day. The other day when trying to make up these lathe tool holders, I had a bit of cutter slippage, and part of that was I was trying to get into a space where I couldn't reach properly with the ER collet holder I had. So one of the things that has occupied me is making up a new collet holder, and this is a bit of a clip on making that up, and guiding people through the steps so they can make up their own extended collet holders if they like. I guess to start with, what are the proportions I'm looking for here? Well, this is a standard ER40 collet holder, and as you can see it's quite wide across there, so if you're trying to get into a narrow gap, that's just not going to work for me at all. Now, I have made up one like this which takes an ER16, and that works fine. The trouble with the ER16 is it stops at around about 10mm cutter diameter or shaft diameter. Okay, so this one is going to be ER25, which stops at about 16, but the difference here between these two is that this one has got a standard nut down the end, whereas this one, to gain a little bit more space, I've put a thread here, and this is actually going to be a custom nut. I haven't quite finished it yet. I'm doing some work on eccentrics soon, and so that'll be the finishing off, because there's an eccentric involved, will be there. Now, there's a standard ER25 nut. That's diameter 42. This is diameter. This is diameter 36. This is 42 here. So it's a little bit smaller, but when you need that space, that's, you know, sometimes you take millimeters where you can. Now, one question people sometimes ask is, well, why this long? And the answer is simply that, well, that's about the length of a standard drill chuck, and so I figure I can get away with that without too many dramas. If I'm too much longer, things start getting more flexible. Shorter, and well, you know, do you really gain terribly much? But I find that extra 50mm or so sometimes is all you need. I have my main piece of stock cut to length. It should be 63. This is only 60. The 63 comes from the standard. I'll live with 60. I'm using my usual technique of putting the 3-door chuck and then very carefully, slow speed, put some centres in the end so you can support the thing properly. One of the things with black bar, there are people out there who say, well, you shouldn't have black bar in a 3-jaw chuck, it doesn't hold it properly. I come from the school of, well, you've got to hold it somehow. So I put it in there. But one of the things you can see here, if I start this up, as you could see, the centre was wiggling all over the place. So I put using the techniques I showed in a previous video, I put a punch mark there just to give me an idea where the centre was, and that's because of the effects of the black bar here. And so there is actually I won't say a sweet spot, but a better spot. And if you rotate, if you have yourself in that situation where you think, well, that centre's way out, if you rotate that carefully, you can find a spot where that deviation is minimised. I don't know whether that's terribly much better, but I'm now going to put my centre in there, pop a live centre in there for support, clean up the outside here, so I can then flip that over and clean it up. My first shape is going to be basically a flange in the middle here with 2 reduced diameters here. That'll help me put it into the chuck or down the spindle bore, give me somewhere to grab onto with lathe dogs and all the rest of it. I've roughed out my blank, as you can see. The bottom is a few millimeters larger than the largest diameter of the taper, and the top is a few millimeters larger than I think I'm going to need for my thread, which is going to be 1.25 inches, so it's about 35. Cutting a taper on this lathe is rather interesting because the bed's worn, and so I never quite know where the axis of the tailstock is with respect to the axis of the headstock. So to cut the best taper I can, first thing I'm going to do is put in my test bar. This is a ground test bar, and it's the same diameter here and here, and by running my carriage up and down, I can see whether or not the tailstock is aligned. Does it need to go this way, or does it need to go this way? Over the length of that, which is what, 175 to 200 millimeters, I was out around about 4th thou. So I've just brought the tailstock over. When you adjust your tailstock, one thing you should look at is down here is the locking lever for the tailstock position. So it's one thing to adjust the bolts either side to move your tailstock back and forth, but you really need to let that go, then tighten it up again so that things have a chance to relax and then tighten, so you get that in the right spot. The taper here is defined as 7/24 for both sides, which means the angle I need to do on one side is 7/48. So for every 48 millimeters, I need to come out 7. Now, you can make that work for you, because if you have your dial indicator there and you set up whatever it is you're going to use to do your taper, your cross slide or a taper turning attachment if you're lucky like I am, it means that if you wind that along a certain distance, you should see that indicator move out by whatever that proportion is. And so if you've got a tape you haven't got an example of, you can't copy of anything, that's one way to get round it, is accurately mark, or better still if you've got a DRO, accurately mark out a particular distance, maybe 48 millimeters to keep the math simple, wind your carriage along, and once your dial indicator travels in or out, depending which way you're setting this up, 7 millimeters, you know that you've got 7 on 48. On this lathe I've got a taper turning attachment. For those of you who haven't seen these before and know how these and don't know how these work, what it is effectively is a beam which is secured to the bed so that it's stationary, and there's a traveller which is attached to the carriage, and by inclining the guide here to a particular angle, that carriage, as this moves back and forth, the carriage moves across. This is a particularly good taper turning arrangement because the lead screw automatically disengages here. It's got a spline on it. Some of them you have to actually disconnect your lead screw and then use it, but for doing tapers like this, it means you can get power feed and get that taper. It's also useful for cutting tapered threads as well. This is the taper turning attachment all set up. So when I wind the carriage along, basically the needle on the dial gauge stays pretty much in the same spot. There's a few bits of cyclic stuff which I think is lead screw, but you can see that the angle of the guide over here pretty much mirrors the taper. So I can now put a turning tool in here and turn along. Now the nice thing about this particular device is that I've now got that angle set. I can leave that there. I can disassemble it, so I can do straight turning, which I'm going to do, and then I can just connect things back up and away I go. I'm still cleaning up, the reason being that I'm now between centres, and you can see there's a little bit of movement in this part when I rotate it. Until I get that out, parts with a big centre and thin ends like this tend to wobble around much more, and so until I get that eccentricity out and get that so it's beautifully concentric, I'm going to have trouble. So slow speeds and just cleaning this up slowly until I get down to a spot where I want to be. Here I am already to start putting the taper on. I've taken that down to size. This one I've still got to smooth up. I've got bands of texture on here just so I can see how the cut's going, where it's coming to. It's something I do quite often, but it's very handy in this situation because this tapered cut ends 1.6 millimeters from that shoulder. After many passes back and forth, this is where I am. So that looks good. I've tried to put a bit of a polish on it. It's difficult. It's sort of mystery variety or mystery grade black steel, so difficult to know what it is or put a polish on it. I've machined up and polished my taper. Before I do anything else, I thought I'd just try and test fit that. So I've taken the drive dogs off the spindle of the mill here. It's just a whiteboard pen, and you could use engineering blue if you like, but I'm just going to cover that up like so. Put that in there, push it up, give it a bit of a turn, and there you go. So it looks like I've got good contact on this side pretty much all the way, and there's a little space up there where I haven't, but I'm going to call this good. I don't know what the condition of the socket in there is like. That could be a worn spot on the socket, so you know, I'm really happy with that. That's a very nice contact pattern. Now normally if I'm making one of these at this stage here, I've got this down to the round about the diameter I want, I would step that down a little bit and put on the necessary thread for the ER collar. Once I'd done that, I'd then probably support that on in a steady, put the drill and put the taper in there, or flip it round and do the same thing this end, and under it be done. But I'm not actually doing that with this one. This one's for an ER16, but this one is for an ER20. Now, an ER20 nut is that size. And when I looked at that, and I thought, well, that's not much smaller than the Weldon shanks that I use for some of my cutters. So what I want to do with this is actually put the thread for the nut up here, having should we say, a thin sleeve that goes over here with the nut features in the bottom here. And that will hopefully give me an ER collet that does up here, which gives me the gripping down here. Only increases that marginally, but lets me get into these tight spaces. Back to that wonderful bit of kit, the Fix Steady. So I've got the arbor set up with some strips of copper just to cushion the jaws on this part. I'm now going to drill this out to the recommended size, which is 18 millimeters, and then I'll come in with the cross slide and put in the 8 degrees per side taper. Sadly, I've run out of weekend, so I'll have to leave it here. As I said, I'm going to finish the nut off when I do a little bit of eccentric turning in a few weeks' time, or a few clips' time. But thanks to those who inspired me, particularly Peter Cooper for introducing me to turning between centres, and we'll see you for the next one.